video, we are going to talk about event sourcing implementation using Axon framework. So in part 3, we gone through the philosophy and the theory around event sourcing pattern and how we should be implementing in a step-by-step process. Here I'm going to actually going through the live code, the services which we have built for supporting warehouse operations. So those services has been rebuilt using the same event sourcing and event modeling pattern. So I'm going to go through and show you how those interactions works, how those plumbing works, how we create commands and events, and how those events looks like in the event store, how those services are talking to each other using Kafka by sending the events, um, so things like that. So let's get started. So just quickly, in we are talking about here all these services, which is basically on the right hand side. These are the warehouse services, the order service, stock service, shipment service, and read-only projection service, which is our query service. They have their own database, and they also communicate using a Kafka message queue, where they actually publish events, and other services who are interested in those events, they actually subscribe to those queues. Um, so there is other part of it. Once the order is finished or shipped, we also publish notification to our retail apps, but that is not covered as part of the event sourcing because this is probably a different domain altogether. We might rebuild in later stage, but at the moment we are only going to concentrate on the order service, stock shipment, and query service. Okay, so let's get going. So just a quick overview around Axon framework. So this is basically the framework which I'm actually using to provide all the infrastructure needs to implement event sourcing, because you need a kind of a pipeline or kind of a mechanism to transfer to publish commands to actually publish events, and we are actually running in yeah, on cloud with multiple pods. So you need to understand the failure scenarios, what will happen if a particular pod who's processing the events got failed or killed, and these kind of things. So all kind of infrastructure, fault resilience, how do we make connections, how do we standardize sending events and commands, all those things are captured and abstract away from the business logic from our services, and it's actually put through into Axon framework. So Axon frameworks provides a lot of other things as well. It provides snapshotting, it provides tracking, versioning, and all those different things. So I'm using this framework. You can actually read more about this framework on their website. I have put the link in my third part blog as well. So what is basically happening here is that imagine that we are getting the orders from supply chain, and they are actually posting orders to our order service. Once order received in the order service, which is our controller, a REST controller, they will that controller will convert that order into some kind of a command, and then publish this command inside the service itself. And then there are kind of a process layer which will listen to the command, find the appropriate event, store that event into the event store, and publish that event so that the other command or the other process who's looking after that particular event can process this event and do the subsequent flow. So let's just quickly go through the process, the demo first, and then we'll jump into the code. So for demo, as you can see, we have few endpoints created. What we will do is we will actually use our create order endpoint, and we will submit order request. and then that our order request will go through to the stock service, checking for the stock availability. Stock service will raise the event saying it is available or not available, and then based on that, order service will create the shipment that will go to the shipment service. Then shipment will actually process that shipment by receiving it, and then finally we will have the order closed. So it's a similar example, is a similar demo what we did last time, but this time it is actually concentrating on how we actually build up our whole event model here. So let's get started. So let's just quickly generate the auth token. Now what I've done is few changes here so that we don't need to provide data. And again, so for example, SKU is coming from the global variables, which I have already set it. So let's just submit this order. Before we actually do that, let me also start um, capturing the events in our event flow so that we can go and examine all the events. Basically what I'm doing, I've just started a Kafka consumer which will actually show all our events so that we can go, once we finish the demo, we can go back and see how those events looks like. Right, so let's just submit this again. Yeah, it's looks like it's created. So if you see the Kafka consumer, we can see that the first events were the order created event. Then the order service sent the inquiry to stock service. The stock service checked it and allocated it. So there are three events happened here. And then order service actually placed the order, and then shipment was prepared and shipment was sent. So now it's waiting for shipment to be either close or cancel. So to do that, we just go to our query service. Now, I will talk about the query service later, but let's just get the shipment ID so that we can just go and close the shipment. And if you see here in our events, there are a couple of more events happened. So it's shipment delivered and then order closed. Now we will go through this. So let me just stop this here. We will go through this in detail. So let me just open that file where we stored all the events. Okay. Right, so I just exported all the events here, and what I will do is I will just format these text so we can see in much better way. And I think the most important thing here, so how do we actually going to correlate all these events, right? So as you can see, these are metadata we will go through later, but most importantly, if you see, there is a event name which is saying order created event, and then there are order details associated. So the most important key here is to correlate everything is the order detail ID, which is a low level detail ID, which every event should have. So if I just search for this order detail ID, you can see that every event has the order detail ID. There is only one event which is saying order delivery, order shipped, delivered. That event doesn't have the order detail ID, but you can correlate using the shipment ID because that should have the shipment ID. So this is how the whole aggregation process works. Now, whomever receiving those events from Kafka topic, they can actually do they can create different projection because they actually getting every piece of details or every change happening during the order processing, whether it's a stock checking, whether it's a shipment processing, and then they can create different projections, different dashboards, different workflow altogether because every time they are getting these information as an event. Now let's just quickly go through our code as well, how the code looks like. So as you guys know that we have four services, so order, shipment, stock, and the query service. The common is just a placeholder for creating all the commands and domain, all the basically all the value objects, right? All the bojos in the central place. So let's just go through the order first, because that is where we are starting our process. So in the order controller, the first thing, let me just minimize that. The first thing we are doing is we are getting the order as a REST endpoint. And once we receive the order, we will send this order to the command gateway. Now this command gateway is basically uh, a class provided by Axon frameworks, so that asynchronously detached dependency on who is actually the receiver of this command. So the framework underneath manages all these things, but we don't really need to care about who is our what is our aggregate or what's our receiving end. We just use this command gateway. We prepare our command object, which is basically a create command, by putting all the information and then push that into the command gateway. Now, of course, as I talked about, the aggregate is basically where the whole workflow happens. So in this case, there is an order aggregate, which will have different methods to handle different commands. So when we're talking about create order command, this method will be invoked, and this method will actually create. You can do a business logic here before you actually create the event, or if there is no business logic, you can just create a event, because you still need to pass this information. So here we are actually creating a order created event. Now the most important thing here is that there will be a event handler either on the same service or other service who's actually interested in this particular event, because once the order created, there is something else going to happen after that, and that process will only be invoked by the event handler. So in that case, if we go to the handler, the order process handler, this is the method which will be invoked once the order created event is created in our event store. And again, here you can do a business logic, you can do things, other things like updating the database and things like that, and then finally you will again invoke a command gateway by sending the um, by sending the command object, which is basically in this case a create stock inquiry command, right? So in this particular case, there is no process in the order service who can actually manage this particular event. So what will happen is that definitely it will go through the order aggregate, which is basically this one, and it will actually create a order inquiry created event. Now the event handler who is responsible for handling the process going forward, it will be in stock service. So if you go to the stock service and if you go to the handler, um, that's where it's actually, this method is actually waiting for that particular command to so event to happen, and that event was stock inquiry created event. After this event is created, then it will actually create another event called check stock command, which will basically go to the aggregate in the stock, and it will basically create two different events based on the condition whether the stock is available or not available, and then raise this event back to the event store, where order service might be interested to listen to that event and do the other workflow, which is basically now creating or placing the order. In terms of query services, which is our read model, query service doesn't really handle any business process. It's basically a consumer of every event so that it can project different projections, right? Or different views. So in query service, mostly if you see here, we will only create handlers, which is we called it projection. So there are two type of handler. One is the order projection, where if you see here, it basically receiving all the different events created by order service. So it's the order created event, stock not available, stock available, allocated, order placed. Those are the events which is basically created by order in stock service, and based on that it will actually update appropriate projection or a view in our database. which is a totally different database compared to the event store. And then there is another projection, which is a shipment projection, and it is actually handling all the events coming from the shipment service. So, which is basically order shipped event, order close event, order shipment cancel, and those kind of things. And it's actually updating based on those events. It's actually updating appropriate views. So just quickly go to our database and see how those events and things looks like. So we have, so we order service and shipment service are using the order demo command database. And in that, when you use Axon framework, it automatically creates some infrastructure tables which framework use to store all the metadata and things like that. So the most important table here is the domain event table, which is basically storing all the different events. So of course we have run few times, so you can see a lot of events, but I think the most important thing to see here is that um, things like types. So every event will have types. For order, we have created three order events, which is basically create order, stock inquiry, and place order. Then there are shipment events, which is also different, three different shipments events. So of course, using there will be aggregated ID, which is our order detail ID, which connects all these different events together. And then there are types and versions, sequence number, which will make sure that when you're reading, you can actually read in order, because you don't want, because these are the delta, so you definitely cannot mess up with the ordering of those events. It has to be in order when we actually reading it. And also some other data around timestamp and other things, which is actually used by the framework to create snapshots and provide versioning and things like, which is a little bit of advanced side of it. And okay, so this is our event store looks like. Now when we go back to the query, which is basically the order demo query, this is this is very simple, and this is kind of a normal database tables here. The most important table here is the orders and orders detail. So that is where we are actually creating a user view, and you won't see a lot of rows here, because every row represent one order, because we are keeping the latest kind of view, what is current situation with that order. You will always go and update that based on the event. So this is the projection. This is kind of a more RDBMS kind of proposition here in the query database. And we'll have the order details as well, which is basically having the product information and shipment information and other things. Sorry, not the shipment, the product information. And then we got the booking. So this is typically kind of a third normalized kind of tables, which have the foreign key, primary key, foreign key relationship between orders, order details, and bookings and things like that, where we are keeping the current state of that particular order. So I think that's it. All the code is already in GitHub, so you can definitely go and check out and see how all these things connect together. But I think that's probably it. I will move on to the next blog, where we are going to talk about more infrastructure services related to service meshes and telemetries and fault tolerance, and how do we dynamically routing request and things like that. So thank you very much.